its wet valve temperature increases and dew point remains constant. Its wet valve temperature decreases and dew point remains constant. Its wet valve temperature increases and dew point decreases. Its wet valve temperature increases and dew point temperature also increases. Here it can be obtained by using psychrometric chart. Let us see. By using psychrometric chart, so here it is dry bulb temperature and it is specific humidity. And sensible heating is represented by, let us say, the process 1 to 2. This is the representation of sensible heating from 1 to 2. Okay, here if you consider here, there is no increase in specific humidity. That means there is no increase in dew point temperature. So dew point temperature remains constant. So and wet bulb temperature can be calculated by using inclined lines. So this is the wet bulb temperature difference. Here let us say this point is 1 and this point is 2. So here there is a small increase in wet bulb temperature. So that the right option is wet bulb temperature increases but specific humidity remains constant. That means dew point remains constant. So wet bulb temperature increases. So here the right option is, correct option is J. A is the right answer.
In this problem, it is given that z is equals to x plus jy, where j is a unit vector and x and y are real numbers. Now we have to find the value of modulus of e power jz. Now we know that z is given as x plus jy. So we'll substitute them. That is equals to e power xj minus y, since j square is minus 1. Now this can be written as e power minus y into e power xj, which is equals to e power minus y into cos x plus j times of sin x. Now we know the formula e power I theta is nothing but cos theta plus I sin theta. Similarly, e power xj will be cos x plus j sin x. Now modulus of any real number is nothing but root over square of the first real number plus square of the coefficient of imaginary number, which is cos square x plus sin square x. Now that is nothing but e power minus y, which is option D.
Question is, find the Fourier transform of e power minus a square x square, where a is the real constant. Here we know that Fourier transform, that is, suppose f of alpha equals to 1 by root 2 pi e power minus infinite to infinite e power minus a square x square e power minus j omega t j omega x dx. If we solve, that is 1 by root 2 pi, the value of this integral, if we follow the standard integration process, that is, we get a square e power minus alpha square for a square. If we solve this one, we will get answer as a under root e power alpha square by 4a square. Hence option C is correct.
In this problem, it is given that a box contains 5 black and 5 red balls, of which 2 balls are drawn one after the other without replacement. Now we have to find the probability that the both balls being red. Now the total number of balls are 10, of which there are 5 red and 5 black. Now when we are drawing the first ball, probability of getting a red ball is, out of the total outcomes, that is 10 10c1, we are selecting one from red, that is 5c1, which is nothing but 5 by 10 equals to half. Now when we are selecting the second ball, probability of getting red is 4c1 by 9c1. The reason is we are not replacing the ball. So out of 10 balls we have taken 1 ball, so the remaining are 9 balls, and out of 5 red balls we have selected 1 red ball, that is there will be only 4 red balls left. So the answer will be 4 by 9. Now the required probability probability is nothing but the product of these two cases, which is 1 by 2 into 4 by 9, which is 2 by 9. Option D. Now, we have to evaluate the integral z plus 5 by z square plus 2z plus 5 dz. Now, in order to find this integral, we have to find the poles of the denominator, that is z square plus 2z plus 5. In order to find the poles, we'll equate it to 0. Now, the value of z will be minus 1 plus or minus 2i. Now, the value of r is nothing but root over minus 1 square plus or minus 2 square, which will be root 5, always greater than 1. That means these roots, these poles lie outside the unit circle. So if the poles lies outside the unit circle, the value of the integral will be always 0. So therefore z plus 5 by z square plus 2z plus 5 integral will be 0. That is option B. Now in this problem, the given function f is xyz cube. We have to find the gradient of f at 1, 0, 2. Now the gradient is nothing but delta f, which is nothing but dou by dou x of xyz cube into I plus dou by dou y of xyz cube into j plus dou by dou z of xyz cube into k, which will be nothing but yz cube into I plus xz cube into j plus 3z square xy into k, which is nothing but delta f. Now delta f at 1, 0, 2 will give you 8j. Just substitute the value of x as 1, y as 0 and z as 2. Now gradient is modulus of delta f, which is equals to modulus of 8j. That is nothing but root over 8 square, which is again 8. So the option B.
A ball of mass 5 kg is falling from a height of 15 meter and it falls on a spring whose stiffness is 100 Newton per meter. What will be the deflection produced in the spring? And the options are 7.35 meter, 2.73 meter, 0 and 3.83 meter. When a ball is falling from some height, it has some potential energy. When it falls on the spring, the potential energy of the ball converts into the strain energy stored in the spring. So here the potential energy carrying by the ball is equal to strain energy stored in the spring. Let us say the potential energy of the ball is given as mgh, which is equal to here mass of the ball is 5 kg and g is 9.81 and into 15 meters, so which is equal to 735.75 Newton meter. Coming to the strain energy stored in the spring, is given as half kx square, where k is the stiffness of the spring and x is the deflection of the spring, and k is given as 100 Newton per meter, so that it is equal to half into 100, which is given by 50x square. Now we equate both strain energy and potential energy, so that we get here 50x square is equal to 735.75. So which implies x square is equal to 735.75 by 50, and where x is equal to 3.83 meters. So in the option, the correct option is D. D is the right answer.